Hello, everyone. Welcome to our to this month's LabVIEW Live event. I'm Jeremy Marquis. I work at G Systems as a engineering technical lead. I've used LabVIEW for 25 years. I'm a CLA, a CPI, and a LabVIEW champion. And I really love getting the community together. I've organized many community events and conferences over the years, and now we've gotten to go digital with LabVIEW Live. Our presenters today, we have a presenter from Virgin Orbit and a co-presenter from G Systems. We have a lot of new people on the call who that may not know G Systems. I think everybody knows Virgin Orbit. G Systems is a turnkey integrator with a focus on test and measurement. We do work in aerospace, defense, energy, RF test, biomedical, and we do design and build turnkey test systems and do consulting on demand. Okay, so let me tell you how this live stream is going to work. I think we've gotten much more familiar over the last few months, but I have some important points for you. If you're watching this stream with the embedded viewer on the page that was sent in the registration email, you are missing out on the chat. There is a link on that page that says watch the stream live. And what you want to do is click that and go to the YouTube site so that you can participate in the chat. The second thing is, if your video is very low resolution, YouTube has automatically reduced it. You can set it manually to increase the resolution using the little gear icon in the bottom right of your video window. So we have two presenters. They're going to be presenting and watching the chat. There'll be a few other people monitoring the chat and see if we can answer any questions. So feel free to talk to us and each other. This is meant to be an interactive event, just like our in-person LabVIEW user groups. And in today's topic, we are extending beyond just LabVIEW to some related tools that you as LabVIEW developers and architects can use. And for that, we have a quick video to help us get started by introducing SystemLink.
SystemLink is a collection of web services and web applications for systems and data management. It includes secure APIs for monitoring, file ingestion, and centralized network communication. It can host custom web applications, including applications built with the LabVIEW NXG web module, as well as custom dashboards and alarms without programming necessary. SystemLink can be extended through a collection of modules. The configuration module enables remote software and configuration deployment to Windows and Linux RT test systems. In a couple of clicks, you can deploy your code and its configuration to hundreds of systems. The asset module automatically tracks connected test assets for calibration, location, and utilization information. The SystemLink test module integrates with NI TestStand as well as LabVIEW and C# APIs to automatically ingest test results and test step information. Ingested test data can be analyzed with built-in Jupyter notebooks and visualized with integrated dashboards. We can also move from measurements to parametric analysis in just a couple of clicks. The SystemLink TDM modules bring the power of Diadem Data Finder plugins, Diadem analysis routines, and Data Finder data indexing to a centralized server, and it can be accessible through a web application. These capabilities enable teams to create common secure backends for test operations, data acquisition, and data analysis. But we face challenges when scaling to larger organizations with multiple teams and multiple initiatives. Enter SystemLink Workspaces. Workspaces provide a well-defined boundary between collections of data and systems and allow users to only see what is relevant to them. Workspaces can be defined by location, product, or another construct that matters to your organization, but it uses security in-depth practices to ensure strong isolation between systems and data in their individual workspaces. Systems automatically produce data in the same workspace that they are members of, which is important because it allows us to move systems between workspaces without having to redeploy code. Users can be members of multiple workspaces, and you must be a member of a workspace to be able to access any of the systems and data within it. When you are a member of a workspace, you have a role which grants fine-grained privileges that define exactly what you can do with the resources within each workspace. Roles and workspace membership can be mapped to common identity providers such as LDAP and Active Directory so that you can enroll members into SystemLink at scale. We have select specialty alliance partners such as G-Systems that are uniquely qualified to innovate with SystemLink to serve systems and data management needs. G-Systems is experienced with leveraging tools such as Python for data analysis. G-Systems is one of the 2 original partners involved with beta testing SystemLink and continues to work closely with NI to gain deep understanding and drive product direction.
All right. Thanks to NI for providing that introduction video for us. So I want to introduce you to today's speakers. We have Omar Mussa and James Duvall. Omar is a lead avionics test engineer at Virgin Orbit. I have known Omar for years. He really knows his stuff, and I know that he likes pushing boundaries. And James Duvall, for years, he's been helping people achieve their goals in test automation and data management. So both these guys are highly competent. So I'm going to go ahead and turn it over to them. Thank you, guys.
All right. Thank you, Jeremy. So we're going to go ahead and start talking about actual SystemLink integration process related things that have basically happened at Virgin Orbit that I've done in conjunction with James Duvall in the last several months, trying to get sort of from concept to practical use cases. So I want that to be sort of the premise. There we go. So really quickly, I know that there was quite a bit of introduction from the NI side, but I will go ahead and go a little deeper into why SystemLink. And really this SystemLink product is all about building data-driven organizations. So I want to talk about the general problem statement that I see it, as I see it, which is that in general, we're a community that's an expert at generating test data, test results, process control systems, all kinds of really amazing things that focus on the industrial automation side and generating data that's of high value. We're not as great as a community at a community level for extracting all of the value that we can actually derive from not just the actual unit that we're testing, but the process that helped generate that that test result or those results. So what we're finding is that as we get further into maturity of an ecosystem, the use cases and the needs for actually driving that business value go up. So, in my view, like the typical evolution of manufacturing data is this. So we focus on generating UUT result data. We basically have some test article that we're testing or some product we're developing. We generate amazing data that shows that that unit works. And at that point, we start moving those products into production. The NI toolchain helps us a bit in that area with sort of production process related items. But we immediately start to see the value sort of decline. We were able to like do amazing things in LabVIEW, do amazing things with sort of creating that rich data that shows that things are working well. But as we get into the systems of how do the business systems that we interact with use that data, our ability to do that really does drop quickly. And then finally, we get into like the supply chain level where we're looking at like business intelligence related, supply chain oriented decision making. And at that point, the data we've collected in our NI tool chain typically has actually fallen to almost zero, unless you've done a lot of very custom work. And so what I think that one of the main areas that NI SystemLink helps bridge is this gap of giving you value further into the right. So instead of having this drop off, which I will just, okay, instead of having effectively a dropping value as we go this way, because we aren't able to use sort of LabVIEW or the tools that are around LabVIEW very well to extract that value. The SystemLink side helps us to flatten that out and get us to go more linearly, or even start to go this way, which is what we really want, which is extracting maximum value out of our data generated. Sorry about this. 1 second. PowerPoint failed. 1 sec. All right. Oh, I have to clear all that. Awesome. Okay. So, so NI has gone from the NI marketing view in my experience. So the LabVIEW NI marketing view so far has been really focused around acquire, analyze, present for quite a long time. Early 2000s, the messaging was acquire, analyze, present. As we went into 2010, acquire, analyze, and present. And 2020 is, if you actually go and look for marketing material, you will find LabVIEW is really dedicated towards acquire, analyze, present. And those that theme has been really solid, and NI has really nailed it in terms of being able to deliver value in that acquire, analyze, present paradigm. But what's happened in parallel is that our needs have evolved. And so what we see is that the test data that we generate, it doesn't really fall into that simple acquire, analyze, present flow. And I mean, maybe to NI's credit, it's not that each of those boxes are represented one state. Each one of those could be a cycle. But in reality now, the cycle is very complicated, and we have our test data that we acquire and analyze, but we also have to validate it, we share it, we organize it, we generate models from it that we then use to acquire new data, and being able to interconnect and couple these things together, and to be honest, create new connections that weren't possible or even visible to us at the inception of the product. Those are the kinds of things that are really where the tooling that existed kind of came short, and where I feel that SystemLink is actually really starting to create a path forward that doesn't rely on building custom systems for your organization. All right, so I'm going to turn it over to James to go forward from here. So go ahead, James.
All right. I'm James Duvall. I've been working at G Systems for about 7 years now. Some of you might have seen me talk about SystemLink on the NI keynote a couple years back. And I'm really excited to get here together with you all and kind of go into some more detail about what we've been doing since then. So let me pull up my slide deck here. All right, let's get that swapped over. Okay, that did not do what I wanted it to do. All right, SystemLink overview. All right, so let's start with a little bit of kind of what is SystemLink. I know we've talked about a few things already, but National Instruments describes SystemLink as an intelligent systems and data management software platform for validation, production, and monitoring of test environments. There's a link here in the slide deck, which will be available later for you to go and see kind of NI's entry on SystemLink on their website. So SystemLink has within it kind of an umbrella of a large number of modules. You know what? There's a lot of organizational tools. One of these organizational tools that's particularly useful is the configuration management module. What this is for is we found systems where we show up to say a factory environment, and they'll have say 20-something testers, and they don't know what test software is running on each of their testers. So the configuration management module kind of allows you to go through and really see like, hey, what's actually deployed to these? One of the really nice things about it is you can actually go and like conduct deployments of software through there by putting together kind of a package and distributing that out to particular test systems. And you can see like when it was last updated, what version's on there, things like that, and it really helps to figure out what condition all your modules are in. There is some interoperability with TestStand. I'm not going to touch on that too much right here because Omar's going to talk about it a little bit more later. There is an asset module where you can basically define assets. You can see like, are they connected to your system right now? When was the last time they were connected? You can do some programmatic control over when things are done with these assets, and you can view the calibration data. One of the most interesting tools that I have found under SystemLink is essentially the alarm system. Now, the alarm system has a lot of functionality in it. One of the things that you can do is basically any skyline tag, which is kind of like a variable for SystemLink. You can go in and set alarms on. So I'm going to go ahead and swap to a different screen here. Let's see here. All right. So this is the basic SystemLink landing page that you get when you have logged in. You can see there's quite a lot here. There's the asset manager we were just talking about. And then I want to talk a little bit about just kind of how this thing all works. So I'm going to go here into the tag viewer. All right, so what you're looking at right here is basically a list of all the tags that this particular SystemLink installation is currently looking at. Now, you'll notice there's a lot of information here. So the tags are defined as these paths along here. You can see my CPU health on the machine that I'm remoted into. And then you can see a lot of current values. It'll tell you what my averages are, how long it's been taking data, things like that. I can then go and configure alarms based off these tags. So I'm going to go in here to the alarms and notifications screen. Now, you'll notice here that someone's already actually set an alarm, and this alarm has been triggered. There we go. All right. You can see that there was an alarm basically on March 18th because we had high CPU usage on this system. Now, you can go in and set up a whole bunch of different alarms. In this case, you'll see that they've already got a few set up for me. They're looking at basically, is my CPU high? Do I have low disk space? Do I have low memory? These are all really useful tools because you can basically set these up on anything and get basically an alarm condition set for, I've got this system out in the field. I don't necessarily have somebody sitting there watching it all the time, and it might not be something I check on very often at all. But obviously, you don't want to come back after a year and find out that there was a lot more activity going on than you thought, and after 3 weeks, your disk filled up, and then nothing's been going on for the last 11 months. Obviously, that'd be bad. So you can go in and set alarms in here. Let's take a look at the low disk space alarm. So what you can see here is basically that they have a alarm configured where if basically over 90% of the disk space is being used, they set an alarm. Now, one of the things you might be thinking is, it's like, okay, what does an alarm actually do for me? Well, notice down here they have already configured a notification strategy, and they basically have called it the low disk space notification strategy. So whenever an alarm is triggered in the system, the notification strategy is basically what is invoked in order to obviously notify people that a problem has occurred. Now, before I move on to the notification strategies, you'll notice there's quite a lot here. We can set the name of the alarm. We can describe the alarm so that when somebody comes in and tries to do maintenance on the system, maybe because an alarm has gone off, we can go into quite a bit of detail under our description here as to what the alarm was, why it was configured, things like that. You can see here we've got a tag search path, basically saying anything under this particular search path is subject to this alarm. And then, okay, so that's, basically, we have the alarm. So let's look at the strategies. So under the strategies, we have a few that are previously defined. So I'm going to go in here to the low memory notification strategy, and you'll notice that they've got an email group already defined. And there's a placeholder address group in here and an email template set up. So if you're wondering, if you think you've got a good guess of what this does, then you're probably right. Basically, what this is doing is this is allowing us to define an email group, and basically they say, hey, whenever this alarm occurs, we're going to go ahead and send a message to everybody in this particular email group, letting them know that this has happened. One of the nice things that you can do with this is if you've configured everything properly, I usually, when I'm implementing these alarms, have several tiers of alarms. Lower tier, kind of like a warning thing. This might be something I want logged, so I might send it to, say, only like an email account that's just basically set there to handle warnings or log things, and probably with a rule attached to it. So it just kind of goes into like a folder that says, hey, something happened. So if I want to look back later and say, did I get kind of high memory usage ever? Yes, I'll have a record of that. Kind of on the higher level of it is I might have a problem that's much more exigent and might require an immediate response. So you can actually go in here and basically set up these emails to operate as a text message. So there's a lot of documentation available online on how to do that. But basically, you more or less are emailing the person's phone number at their carrier. And that will convert into an SMS text message. We actually set this up and had this going kind of at our booth at NI Week a couple of years back, which I'm so bummed there's no NI Week this year. I'm sure everybody else is too, but I'm really looking forward to NI Week 2021. Anyway, yeah, you would just normally do that under the email groups. You can go in and define it in here. I can basically put in, 555, whatever, at att.net or whatever the actual particular suffix is, add that to my stuff, and now I get a text message for that. So when we are configuring alarms, there are several options as far as like what you can check. I can basically any tag that I want, any tag at all. This does not include just tags that have been generated by the system. This includes tags that you have generated. That gives you an incredible amount of flexibility as to basically what you want to do and when you want to do it. Now, they have provided in here by, basically natively quite a few options as far as, making it very easy to set up basic alarms. So, we have all the basic comparators, less than, greater than, equal to, in the range, out of the range, not equal to, things like that. You can even set a deadband so that you don't get a million emails, things like that. Now, you might be thinking, hey, James, I've got alarms that might need more nuance than that. That is actually where LabVIEW comes in. I'm going to go ahead and swap over here to a different. This could be a little more difficult than I thought.
Hey, while you're switching over, James, I wanted to just point out you also can use tokens and things. You're in the example that's shown, there are tokens that you can use to also configure custom messages, so you don't necessarily have to write any code. Depends on what you're trying to accomplish, of course.
Yeah. There we go. Okay. Sorry about that. My WebEx menu kept popping down and blocking me from accessing my get away from my remote desktop menu. All right. So this is a simple piece of LabVIEW code that basically just shows me opening up a tag, my tags.demo tag, writing a value to it, and then closing it. This right here is the foundation of allowing just an extreme amount of flexibility, because I can basically then go in, and you can imagine it'd be very easy for me to set an alarm and notification strategy based on my tags.demo tag being equal to 42 or greater than 0 or not some number, things like that. So let's kind of look down here at a potential application for this. So what this piece of software is doing is reminding me, first off, that I probably should have put more comments in it. In this section over here, I'm basically am loading up a tag that I have invented that has how long my test took. It's called mytags.testtime. So we open up in reference to the tag. I'm reading the tag history here. And then I basically have an array of, I believe it's the last 1,000 entries into that tag. And I come over here and I'm calculating two different average times. One is basically the average time that it took for my last 20 tests to operate, and one that was the average time for my last 5 tests to operate. Now, one of the things you can do is over here, I've got this mytags.shortTest average warn threshold. So this is another tag that I'm simply reading from and using that as a limit against basically my calculated value. So this is a little more complicated than basically the default's going to allow you to do. So I've extended that application using LabVIEW. So in this case, basically, if my last 5 tests took longer than a certain value, I set I get a true out of here, and I go and I write this back to my tags.testtime short warn state. Similarly, I do the same thing up here with the much longer window. And the idea here is that I could then go in and set up an alarm system and notification profile based on one of these Booleans going true. So if I went in and said like, hey, if it's just a short window, if only 5 tests in a row have averaged along, then I might just want to log that or put notification up on a dashboard, which we'll get to in a minute here. But if I have like a really long running situation where my last 20 tests have taken too long, then that's the part where I might want to go ahead and send an email to, say, the line manager, whoever's in charge of the lab, or even a text message if I consider that to be a particularly big problem. This example here is based on the same sort of premise of I'm making my own custom alarm. So in this situation, what I've done is I have loaded up the history of whether or not my test has passed or failed. I'm pulling out the last 50 items from that list, and I'm going through and doing some simple logic on it. Basically on the top one here, I'm looking to see if I ever get a situation where I have 3 tests in a row fail. If I do have 3 tests in a row fail, then I'm stopping my loop and I'm setting a notification that I have a test fail streak warning. And again, my notification strategy there is going to basically vary depending on how much of a problem I consider that to be. Down here, I'm counting out of my last 50, basically how many situations have I seen where I felt like, we failed. And if I didn't pass enough out of the last 50, then that might be a more concerning thing. So I've got another alarm strategy set for that, where I basically set this tag here to basically be true if I'm having a failure trend, essentially, that I consider to be a real serious problem. So as you can imagine, there's a lot of ability to go in and make this very extensible and come up with very complex logic. One of the reasons why I felt that it was worthwhile to kind of go into a few of these strategies is that we've had customers in the past who have had advanced things that they were looking for, metrics they were looking for, footprints, signature type testing, where, for example, they wanted an alarm condition if, say, an event happened, say, 3 times in the last 10, or an event happened 5 times in a row out of the last 30. So again, very extensible. Go back to my slides here for just a moment. Okay, so again, things that you can monitor are your available hard drive space, your CPU loading, or any Skyline tag. Some of the new some of the new Cerio chassis will actually go through and populate a very large number of very interesting tags for you. So if you've ever had that situation where you're even just in development, and you're wanting to see, hey, am I running into a problem of mine or spiking my memory usage, things like that, those are already in there. So this is also a very useful tool for simply just under development. So we talked about notifications and looked at that. All right, let's talk about dashboards. So dashboards are very easy to configure in SystemLink. They're very, very flexible, and you can put data as a display or data as a control. So I'm going to go ahead now and swap back real quickly to my SystemLink machine. So, all right, a lot of stuff in here. Hi, kitty cat. All right, so this is the dashboard menu. Some really fun stuff you can do here. You can basically create a new dashboard or import a dashboard. The imported dashboard feature is very useful because it gives you a way to basically kind of move, gives you an opportunity to basically make it easier for more people to work on dashboards and share dashboards around. When we made several dashboards for our NI week presentation, NI was able to basically help us out with that. We worked with their team and we're able to get some really neat dashboards together. This is a demo dashboard I started kind of throwing together. You can see here I've just got like a graph and then a numerical display. I'm going to go ahead and open up the editor. Oops, wrong button. Let's just really quick go through creating a new dashboard. So I'm going to give it a dashboard name. I'm going to say this is my live dashboard demo. And you can see down here, there's an option for basically tile-based or free-form. I'm going to go ahead and open up a free-form based dashboard. And you'll see quite a lot of tools here. I've got outputs, I've got inputs. I'm going to go ahead and say that I would like to put in a numeric output. And right now it just says 0. And I can go over here and there's a lot of flexibility in this as well. So in this particular case, I've got a value of 0. It's in here. If I open this up to say 5, you'll notice that it's updated. But I can also go in here and bond this to a tag. So if I go back here for just a moment, I'm going to save this. We'll come back to it in just a second. Let's see, lost the save button. Oh, sorry, there we go. All right, so if I go back and look at my list of tags and find that I've got a tag in here, and let's find an easy one to remember. I've got localhost.health.disk.used. So I'm going to go back to my dashboard editor. And then I can go in here and say, hey, I want localhost. And you'll notice it started to pop up here as soon as I typed it in. And I can put that in. And now that field is bonded to that tag. So then if I basically go live with this, now you'll notice that I've got that value in there. So that is essentially the foundation for putting all these dashboards together. You can bond tags not only to things that you want to display, but also to control surfaces. At one point, we actually created a really nifty little thing that would allow us to basically change the color of a numeric output based on whether or not the user was trending ahead or behind. So it's a lot of functionality there. We basically, for that, we would just go in here and say, on like the background color, for example, you can bond that to a tag. You can set that tag via LabVIEW.
I'd like to add one thing really quick. There's the tags themselves at the bottom below the on the left side, there's actually a search tool to find tags and display them,
that's
so you
true.
don't have to you don't have to switch context
I totally
for that.
spaced on it. Thank
That's
you for
okay.
pointing that out. Yeah, yeah. So if I go in here, localhost, health, it's actually all arranged. You'll notice it kind of follows it doesn't kind of follow. It does follow the dot logic. So localhost dot health dot CPU, and then there's my CPUs and all of the stuff that I need underneath that. So very well organized. And again, you can also access it by starting to type it in over here. So let's see here. You can also basically define these as inputs, and you can go in and like I can put in a numeric input, and I can similarly connect that input to a tag and use it to drive things. The application for that is like you can have, for example, one dashboard that we created in the past was a dashboard that would actually put data out to basically like a large TV displayed in a factory setting that showed them like, hey, here's how many you've got for this hour, and this is how many you need to get for this hour. Well, underneath a more primitive system, you might have a problem with like, okay, let's suppose you want to do 100 an hour, but the first half hour of the day is taken up by a team meeting or something, right? Well, obviously they know they're not going to hit that 100 mark, so they might be inclined to be less concerned about it. So you could go in and then update, basically from an administrative dashboard without having to do any code work or anything like that, and basically update temporarily that value and give them a new target that would display on the basically user-facing dashboard.
I'll just my other 2 cents about the dashboards that I like to throw in is one is that there's those 2 types, the tile-based and the freeform, and the tile-based are more for sort of like statistics or sort of rolled up dashboards that you can think of as sort of like business level dashboards, whereas the freeform ones lend themselves more for the use cases of like interactivity or, for example, if you wanted to track assets on your factory floor, you could create a map and have graphical representation of the assets on your floor and use the asset manager tags to kind of bind that all together. And those are the kind of use cases that I see for the freeform version. Just wanted to throw that out there because we're kind of using those constructs internally as well in those ways.
Yep. So all in all, dashboards are very easy to use. The import-export tool makes them easy to share. It's very, very quick to basically prototype a dashboard. And there are tools to make some very impressive dashboards in there. It just kind of depends on what level of development you want to have on that, how much polish. For an administrative dashboard, we usually put it pretty, it's pretty Spartan, more focused on functionality. But if something's going to be sitting there floating around on your factory floor, obviously you want it to look really nice for anybody that might come through and take a tour. So there is some limitations on the interactivity with the dashboards right now. There's certain limits on the complexity of the logic that you can put in, but I encourage anybody who's interested to take a look and see, and I think you'll find that there's quite a lot you can do with the tools that are available. All right, Omar, do you want to talk about this slide?
I think we can skip it. I'll just mention really quickly that in terms of the way SystemLink is organized, there are kind of 2 areas that we care about. There's the server configuration itself, assuming you're not using the cloud, which NI takes care of the server configuration in that case. But you have sort of like which apps you're exposing and that kind of stuff at the server level that have to get installed and configured via NI package manager. And also there's some server configuration tools that also you have to run. There's additionally the web server configuration, which is related to which apps you expose through the web UI. So if you noticed, and we'll show you a little bit more later, sort of which application modules are exposed to the users. And then additionally, there's machine level configuration on the server. So for example, there are customizations you can make, which we'll show later, that will enable custom applications to become visible. And there's other ways you can do things like automatically execute scripts and things of that nature. So the main point of this is that there are server configuration related things that you have to do in order to set this up properly. And there's also sort of minimal, but sometimes there is some client related information you have to set up specifically for the nodes that are connecting to SystemLink for publishing data. If you're just browsing data on SystemLink, you're using the web user interfaces, and that doesn't require any client configuration at all. And that's all I would say. Go ahead.
All right. So I
Okay.
think we're going to go ahead and switch over to Omar for SystemLink in action.
Okay, yeah. So I will build on that a tiny bit more. So I wanted to mention, we kind of jumped straight into some use cases that were low level, but it is worth noting that the way SystemLink is architected, it is a client server based system, and the SystemLink itself, like the server is consisted of both an Apache web server, a Mongo database backend. There's like a application level modules. So there's a bunch of different things that sort of SystemLink is. And you don't have to directly touch any of them, but it's worth noting that that is kind of how SystemLink is set up behind the scenes. And when you are interfacing with the various NI tools, you're indirectly interfacing with those other backend products. What's nice about those backend products is that those are all very, very public, commonly used tools in the spaces of like web and data related, like web server using Apache is, I believe, the most common web server in the world. Mongo database is a very popular document database. So these tools are very modern and are very much public and non-proprietary, non-customized. If you think back to like the older tools that NI has produced in the past, where there might have been more customized or even proprietary systems that were built up that are very difficult to have long-term maintenance plans for, that is kind of, they've evolved away from that in great ways, and that's something that I really appreciate. I'm going to start sharing on my side again. Okay. Great. Okay. So I want to actually go straight into the test monitor side. So one of the things that I think we talked about some of the types of modules that are usable. One of the ones that's super valuable is being able to visualize your data results. So in order to do that, I'm going to quickly show how we can produce some data, show some data changing on a dashboard. In this case, the dashboard is the test monitor itself, which is an example of a tile-based dashboard, and also show some of the simple analysis that you can do out of the box with no programming. So I'm going to take one of the things, I am not a huge TestStand person. I will honestly say that I don't avoid it in all cases, but I try to be very careful about when I use it to make sure that I'm getting the most value out of it. One of the things that TestStand and NI has done really well with TestStand is made the SystemLink integration remarkably smooth and seamless. So at the configuration level, it's literally, you have your existing sequences. This is an example, just a shipping example of the computer test, motherboard test. In order to set up your quote unquote SystemLink setup, you go to the results processing configuration, and you basically enable SystemLink by saying, I've got the SystemLink client, and you can configure some simple options. I just have everything checked because why not? But you can do whatever you need to do here. You don't have to modify your sequences. You don't have to modify any station parameters or anything like that. And you basically, by running your sequence, get for free data getting piped into SystemLink. And the data is actually organized in a way that makes sense and is fairly logical. And the reason that I'm actually showing this demo first, and I may abort, okay, good. I'll just, the way this demo works, in case you've forgotten how the shipping example works, is any of the boxes you check causes a test to fail. So I'm going to just cause a test to fail. So it's just running. You can see that there's nothing that looks special about it. You don't see any SystemLink related anything because all of that configuration happened through the backend connection on that configuration page I just showed you. What you end up with is data in SystemLink that you can then visualize. So I'm going to go to the top level test. Oops. Yeah, thank you. And yeah. So the test monitor results that show up on the dashboard level, this is an example of the test monitor dashboard. It shows you which tests are running, which ones have failed, that kind of information. You can click on any of these tiles to get to detailed information about that specific set of tests, and you'll see it'll pop up, including the test that we just ran. And then you can dive into the actual tests themselves by just double clicking and sort of diving in. I've already done that, and I'll save a little bit of time to get some data, not have to wait for any server client response. I'm running the server on my virtual machine in a very constrained system, so it's a little bit slow and not as awesome. So what I will show is, so you have your results that show up in here. One of the things that we want to do all the time in the test world is compare passing or compare results from one serial number to another and show that they're in family and things of that nature. So you have your test results that you've got loaded up. You can click on this configure graph button and basically add serial number as a property and have to apply that. And it will now show up with all of the serial number data in the dashboard visible, which is great. So I can do my family level comparisons. This is trended by time. In this case, the time is actually just like the instance of the test, so test 0, test 1, test 2, but it could be date-based if you choose to. You also have the ability, based on just sort of, this is all no programming, nothing customized at all. Mousing over the points, they automatically show up with annotations, so you can kind of find details about that given test point. And there's all the additional features, like you can choose to change the time basis to go to elapsed time and just bin them together and get a histogram of the different results. All of this is done with no code and sort of gives you a very quick and very useful measurement of your ability to analyze your system results. Writing this from scratch, like taking TestStand results and basically having to then parse the test reports and then figure out how to get the data out, or custom writing it to your database and then writing custom tools to pull it out, all that work is basically done for you and lets you go straight into the value-oriented part, which is understanding why you had failures and using that data to try to better improve your test process. Okay, so that is a really fast example. The other reason I wanted to show that example, though, is that the LabVIEW, the test monitor API, whether you're using LabVIEW or Python, is 100% based on this TestStand model. I don't really, there's an argument called model, and if you don't use the TestStand model, I don't think you get all of that dashboard integration for free. So I don't really know yet why you would use that other than in TestStand mode. Or the TestStand data model. From TestStand, although you don't have to do any customization, if you want to do additional customization, like automatic adding of keywords and properties and other kinds of metadata, or notifying via email that something went wrong, you can do those kinds of tasks as well by adding custom SystemLink test steps into your test sequence. But again, the data use cases that I showed just now required none of that. And if you used the email setup based on tagging alarms, as James showed earlier, you can actually get sort of automatic emails sent out without doing customization on the sequence itself. So you can actually do quite a bit out of the box, and again, without modifying your existing source code, which is a very nice feature because we all know we don't have to revalidate changes unless we have to. So I want to go really quickly into the LabVIEW version of that. So LabVIEW APIs, there were a few examples like of the tag API that James just showed earlier, but in general, the LabVIEW SystemLink APIs show up under the data communication subpalette. or if you use quick drop, you just control space and start typing what you're looking for. But anyway, the test monitor API specifically is only available in LabVIEW 2018 plus and greater, but other versions of the other APIs are actually installed separately. So if you want to do configuration management or asset management or various other kinds of operations that don't require test monitor, you can do that in older versions of LabVIEW with no customization. We were able to also roll our own pre-LabVIEW 2018 spin-off, I would call it, of the test monitor by just calling HTTP APIs from LabVIEW. So there is a way to do it if you have older code and you still want the data to go in and you don't want SystemLink to be the reason you upgrade. It is still possible to get your data into a consumable format that that SystemLink can use. The most important thing that I would like to say is that while these APIs are good and they're very friendly and very useful, one of the most important parts of planning for using SystemLink at an organization level is to plan to create custom API wrappers for these functions that you are going to use. For the most part, you're going to want to have consistent data and consistent metadata in order to make the backend tools useful. So you can imagine that if you have the word serial number and you have the word serial number, but they're spelled differently, or some, there's serial numbers, maybe not the best example, but you can think of many use cases where the either case sensitivity might affect you, or just somebody added a space or decided to do no spaces and added a hyphen. When you have inconsistent data then you're going to have a very difficult time pulling that data out. So really one of my main points of emphasis is that you should plan to create APIs that prevent that from happening. The cleaner your data is going in, by far the more value you'll get getting it out. And at the end of the day, one of the most important things about SystemLink is that you are worried, you're starting to treat data as a first-class citizen, and your focus is on how do I extract the most value out of the data I create. One of the most important parts about that is creating good data. Here's the shipping example for the LabVIEW API. And it actually makes it easy to see what I mean about wanting to create wrappers. By default, they have, it's a very good shipping example. It functions out of the box and it gives you a good idea of like what data does, what data properties sort of affect your results and in which ways. And you can quickly kind of prototype stuff with the dashboards that they have and make sure that the way you're writing code works. Again, if you're using TestStand, you may not actually need to log through the test monitor, but maybe some of your other either legacy code or some other features that you want to log data to that API where you end up wanting to use the test monitor, or you're just having an application that's not coupled to TestStand. Any of those cases, you could use the test monitor APIs, but you're going to want to avoid things like, again, properties and keywords just being sort of nakedly exposed so that you can create all kinds of typos and future problems for yourself. So that's where I've found the most value, is basically in creating classes or data structures in cluster form that basically, even enums and things of that nature, that basically just force the data to be very strictly defined, so that as it gets into SystemLink, when I'm trying to pull it out later, I know what I'm looking for. Another reason that I wanted to go through that TestStand side is that the data itself is very much following the TestStand model. So you can think of a result as sort of a placeholder word for test sequence. And then so you're sort of creating the sequence result level, like sequence level data. And then there's test steps, which of course you can name however you want. But inside of each step, there are test results. So for example, your test step has inputs and outputs. Inputs are things that you can use later for parametric analysis. So if you have, let's say, a bunch of RF input powers that you're sweeping over, and you want to check some output DC voltages or vice versa or whatever, you can basically use the input parameters to make the data you're coming out with parameterized and manageable and reportable. Another example of sort of wrappers that you want to think about for yourself, this VI is called add test step measurement. Oh, one other thing I really like about the API is they're very relatively open. There's very few VIs that have closed block diagrams. So I would not recommend modifying these VIs, but at least you can either create your own copy and modify, or use them as documentation for what your expectations are and what you're supposed to do with the data, with the functions themselves. But you'll notice that, for example, passing data in to the into this add measurement, it's expecting that you have manually done your own analysis of, is the value passing or failing? So if I put down, is this value equal to 0, and I mark it as failed, even though my value is 0, that's really enabled because the API is designed to be very flexible, which is good, but then it means you should think about writing your own custom wrapper around that to basically handle your evaluation in your use case so that you don't end up with different things resulting in pass fail that are not what you expected. And again, you end up writing your overall test step result manually as well. Like, I declare that this thing passed. And anyway, those are the kinds of things you can do to write the data manually from LabVIEW. Sorry about this. I'll do it this way. So what right now, you cannot tell the difference if you go into this test results query. You won't see the difference between whether the data was output from TestStand or from LabVIEW, except
Sorry.
except for possibly by the actual program name or something of that nature. But you, from the end user, who's the data engineer or the person who's going to review the results, they actually won't know what the source of your data was. For them, it's a fluid response, fluid experience, and it's, again, the data analysis part is very much decoupled from the data generation, which is very nice. Okay, so that's the API side. So examples of things that are one other kind of key important distinction is the difference between properties and keywords. So properties are string value pair items. So anything that you're going to define that's going to have a value, you're going to you can use that with custom properties. So for example, a job number or a procedure number or something of that nature. Those are test properties that you can then use later for extracting data. There's another type of attribute of the data called the keyword, and you can create keywords, and I like to think of them as sort of like hashtags. So things that you can use to tag your data with a equivalent of like a hashtag. So something like an event name or some other binary thing that you want to be able to search against that's text-based. Those are really great opportunities to use keywords. If it's going to have multiple values, it's not a keyword because depending on how you want to use it. But in general, if it's something that's more like of an enumerated data or something that will change every time, you're definitely going to want to use a property for that. Another consideration is that the measurements themselves are really designed for scalar type data. I know it can support passing in an array of values, but in reality, like, where SystemLink does really well is not in storing your giant, gigabit data rate data. It's really well designed and suited for handling the measurements that are made on that data. So while it's great at doing things like if you have a min-max measurement and you want to look at all the min-max values for some certain array, it would be not as good to do the entire array in. I think you'll find that the data space and the data tooling doesn't really work as well for that, at least in the current form. And I could be wrong. There might be other people who've had different results than that, but my view of it is that I can use it to find data I care about and then dive deeper into that data if it matters. So not really raw data, more of results management. Okay, and another thing that's really important, these properties and keywords do not have to be statically defined at the time you create the result. So you can edit them later. You can add and remove them later. And so they are metadata that travel with the data, but can be modified. They're mutable. Okay, so one other thing I wanted to quickly go into it about API wise is the asset module. So the asset module is probably the most trivial of all of their APIs. It really just has a start, a stop, and an asset name, which is great for doing things like tracking. Well, by default, it'll actually automatically track all of your NI assets. So things like if you have a CRIO and it's connected to your SystemLink client, it'll automatically publish things like usage or calibrations expiring or anything of that nature that NI can extract. Even like CPU usage and memory usage and things of that nature get published as tags automatically for NI assets. So it's pretty nice. But you can additionally add custom assets. So things like thermal chambers or some other like custom asset that your organization might have that you want to track usage of, you can also do that. The one thing that I found that was a little bit tricky is that you have to create a JSON file that goes onto the client machine. So the asset ends up being bound to the client, which is a little tricky. This asset JSON structure that's here is not actually in an obvious location. So I had to get help from NI to kind of get this information. And the location where you store it was also not obvious. It's sort of in a random, like, well, not random, but in a non-obvious location on the client machine. So anyway, I included this here, and I wanted to make sure it's clear to people how to use that information so that if you are rolling your own later, you know that you do not have to be blocked by the fact that an asset you want to track is custom. Okay, and then I think definitely in the time where we want to get into the most important part, which is, in my view, extending SystemLink. So how do you go beyond sort of the initial base tools that they deliver and add additional custom value that's organization specific and make that useful to you? Here's a really interesting, I grabbed this slide off of the web. It's not something I tried to create, but this was an example of a data science tech stack from 2020. So there's a lot of tools up here. I will not lie when I say that some of these tools don't seem to go together in ways that are obvious or even, yeah, there's, it's questionable value in terms of throwing them all on one slide like this. But the point is that the tool chains and the tool sets that data scientists and data analysts are using for reviewing this engineering data and trying to take it to the next level is pretty wide and broad. And a lot of it is not in the realm of sort of traditional LabVIEW expertise, especially as you get into like the machine learning and other areas. Other tools like Python have definitely emerged as very high value and highly adopted platforms for taking those data processing steps. So, so the first thing that I would like to say is that one of the nice features of SystemLink is that it has a built-in Jupyter server, and they have a pretty nice demo of using their API, which I'll just quickly show you all. And I will also mention that this is something that I got exposed to at NI Week last year. I was not aware of this at all, and I happened to make it to a Soliton presentation on how they were using SystemLink for machine learning, which they turned into this blog post, which I highly recommend. It's very, very detailed and talks about sort of the workflow of developing a machine learning based automation system. And so I was very excited about that. And I wanted to share that with you all. I'm going to show the very dumbed down version right now, though, which is the version that basically is the shipping example with a little bit of tweaking. So I'll get to that in a second. Here it is. So that's here. So basically, the Jupyter server that is built in, you just check a box at install that says, yes, I want to use Jupyter server, and boom, you have a Jupyter server on your SystemLink server. What's nice, I don't know how many people are using Jupyter, but in fact, if you put response in the chat would be interesting to know if everybody's using it or if it's sort of relatively small group subset of this population. But what we found is that SystemLink Jupyter is a really cool interactive notebook experience that's designed for sort of making it where engineers can interact with data that they've looked at, that they've created. And you can also use it to generate reports and things of that nature. So the shipping example, which I have basically shown here, this is an example of a report that's being hosted inside SystemLink. I can rerun it to get updated results as I need to. It's not dynamic. It's designed, in fact, where you can run cells separately. So I can choose to just run this cell. Run. It'll just rerun that cell and get me an updated tree in a second, or whatever the table that it was doing. And you can see that like I said, my server is not optimized, so I purposely do not want to wait for the rest of those results to come back. But the point of it is that you have these really rich APIs, and you can actually go into the code view and see that basically there's Python code behind each of these cells. And this is very, very familiar. Like, this code doesn't look special to anybody that is using Jupyter notebooks on a regular basis. But inside of these example notebooks, they also have how to connect to the test monitor API from your notebook itself. Because the notebook is hosted inside of the SystemLink server itself, all of the permissions are automatically passed through to the notebook from whoever's logged in. So you don't have to deal with figuring out how to handle security and things of that nature. It's kind of taken care of for you, and you can just focus on using the API to get data out. One other really, really beneficial thing that is sort of built into SystemLink experience is that the APIs are available from the SystemLink context that you're looking at. So if you're in this Jupyter notebook view, you can check for the Python APIs, and it will pop up with, here's the Python API documentation. And wow, my computer is slow. So, oh, it did load up. So here's like an example of the Python module information, and you can, use that as you need to. It's all very context specific, which is nice. But these examples that NI provided were really useful for just demonstrating how to grab data, but also how to process that data and to take advantage of some of the sort of off-the-shelf features that people use all the time with Python, for example, pandas and matplotlib. So that's sort of like where the starting point is for us. We actually had, in our organization, a lot of notebooks that we were using for doing processing of unit results and things after we've published data to our internal file systems and things of that nature. And we were able to refactor them pretty quickly to use to point at our data in SystemLink instead, and then integrate with that as being our data process being driven by the SystemLink results instead of whatever the local results were previously, which was great because it means all of a sudden our workflow can become more automated. And the other thing that's nice is that the SystemLink services themselves have a Python notebook execution API. So you can actually have other parts of your system invoke notebook executions. That gets back into what I kind of mentioned earlier, which is that there's some things that are sort of server-side configurable. And so you can configure on your server that, for example, if some property gets updated in some location, it triggers a notebook to get executed. So that's very, very cool and lets you do really elaborate and very specialized workflows. And the one that I have, this example is a weak example. It's useful from the perspective of it's the shortest path to entry, and the data and all the code is open source. But I do highly recommend you look at the Soliton example that goes into their method of using TensorFlow and trying to show sort of a workflow around doing intelligent data analysis and just, machine learning based systems. Okay, so that's what I'd like to say about that. And then the next area that is of high value to to a lot of us is basically being able to take these SystemLink experiences and go sort of think of them as being extendable, where you can create your own custom APIs. And again, actually, I got inspired to do this based on that Soliton example. They used an Angular-based web UI in their demo, and they didn't release the code for that, which was one thing that I was disappointed in about it, but it forced me to create my own, and I actually used Vue.js based on some other sort of interest. And I will show you some of how that is set up now. Oops, 1 second. Here. Okay. So one thing that's interesting about sort of getting, well, okay, I will just mention first. So the applications themselves can be hosted inside of SystemLink. So for example, this SystemLink View example plugin that I'm mousing over now is a custom application sub-application that I've written that can now fit and be a seamless sort of user module that I can use SystemLink's native user security, and also like the web server side, I can configure who can see this application and that kind of stuff, so that when a person clicks on the button, they'll get results. But in addition to that, most web development happens locally, and you have to do a lot of other sort of, you don't want to have to develop on the server. So what's nice is that the HTTP APIs that they have make it possible to do something completely different. So in this case, I've been developing my application using Vue.js, which is a popular JavaScript-based web application development tool framework. And so what's interesting about it to me is that I'm able to locally develop, and in this case, my local machine happens to be the same server that I'm hosting for this demo, but it could be a different machine. And in fact, because of the different port, the application sort of believes that it's a different machine, that it's on a different machine than the SystemLink server. So I can actually test this as it would be done for development purposes on, as if I was on a different machine from the server. Okay, so in this case, you can see I've no longer sub-moduled the application. So in the SystemLink example that I showed initially, we had the application running as a module inside of SystemLink, but for development purposes, I'm running it completely externally. And what I can do is I can interface with the results that I have. So for example, in my example that I'm sharing this code, this entire code base will actually get published to GitHub later today. I just need to do a couple more tweaks to make sure I have some documents or comments clear enough for other people to understand them. But anyway, I have two parts to this example that I want to demonstrate. One is server-side filtering of the data. So the way that I've got it set up, if you select all results, it shows all results. But if I select approved results, it does a query to SystemLink and returns only approved results. This is really just designed to show you an example of how you can grab data using the HTTP APIs and how to actually, use the server-side features to do filtering, so you don't have to do client-side for everything you're dealing with. But on top of that, because we live in a client-based world now, you can also do rich client features. So this is a filter that I also have that I can use for filtering the results that came from the database results. And this filtering is happening on the client itself just by using sort of JavaScript native features of this table. So the point is that you can get the benefits of integrating these custom web apps that are effectively like very common for creating custom workflows and whatnot, but not coupled in any way to an NI tool chain, other than the APIs themselves are APIs into SystemLink. Why do we care about this? One of the reasons we care about this is because the alternate to doing it this way is to use like a LabVIEW web UI, for example, or some other kind of tools. But you also may have existing infrastructure, like in our case, we have existing infrastructure that was written by a web team. And this makes it possible for that web team to extend their infrastructure to now, integrate with our server results without having to, come up with some new intermediate or hybrid application or whatever. They can just start using the same exact web APIs that we're using here. And that is really valuable. Another thing I wanted to point out that I really appreciate about the way this API is set up is that similar to how the Python APIs show up with Python-specific documentation, um, oops, that is not, let me go back here. The HTTP APIs, they actually can show up using Swagger. So what's cool about Swagger, for development purposes, one of the things that I think is kind of really important is being able to interactively work with the data and with the services and kind of understand how the different API calls are used and what are the properties that you want to tweak and things of that nature. So built into the web API tool chain is Swagger from SystemLink. And so the Swagger integration makes it possible to do things like test out what happens if I do a query. So I can say get products. It gives me really nice detailed information about how the query should work, but it also has this nice little try it out function where you can specify what you're looking for and whether you're looking for any number of products or whatever. There's some simple like arguments, and then you can hit execute and it generates for you the exact query that was sent and also gives you back the data that was returned. So you can use this as sort of a very quick prototyping mechanism for validating that you're using the APIs that you expect with the properties and fields you expect. For me personally, this made it really easy to rapidly prototype the API calls and then not have to worry too much about like the application. Am I calling the right API, and just quickly focus on application logic and make sure that that was done correctly. Okay, so that is kind of what this does and what it allows you to do by using these APIs. So earlier I mentioned you can have properties and things that can get interacted, that you can interact with and update later and things of that nature. So I can actually right now approve data in this simple example just to set some metadata tags on these records. And what will happen is that those actual records will get updated. So now if I do approved results and I look for the server filtering to happen, you'll notice that it happens to persist. And this is a persistent value because I've updated it live in the database itself. And so that's pretty much what I wanted to show on that side. See if I had, yeah. So one other thing that I use as a tool. So while Swagger is kind of built in for integration purposes, really, really useful. I also had occasionally had difficulty knowing whether I was doing something correctly. I also used Postman, which is another tool chain for sort of interacting with web APIs, with RESTful APIs. And I could use that to validate that things like when I was running an application that's not hosted in SystemLink, that I'm passing in credentials correctly and things of that nature. So those were the tools that I actually had to use intimately in order to sort of get to a functional application. Obviously, this is not a very complicated application example, and our applications are a little more complicated than this, but it does get you off the ground and get you past that first step of like, what are the tools needed to kind of build custom web apps and where do files go. The documentation, I will go back one other step, which is, I didn't put a link to it. Okay, there's one other link that I will post later, which in the actual GitHub location where I put the source code for this, that has the example template from NI on, which is what you use when you generate a web plugin. That's what they call these. And so when you generate your own web plugins, what I found was that the documentation's there, but some of it's a little confusing because of the way that things are organized. So my hope is that when I publish this to GitHub later today, you'll be able to use it to understand the points that I got confused on and hopefully not have to trip on those as well. All right, cool. So with that, I think we can go to if there's more questions, or I'm not sure where our next step is. I would like to really thank, first of all, James Duvall and Russell Blake at G Systems for their help with the project specific stuff. But I'd also like to give a big shout out to NI and specifically Josh Pruitt, Matthew Viterlis, and Mark Black for the materials for today. They've been really instrumental in helping make sure that we were successful in getting our foot off the ground and getting this into a position where we could even be having this discussion today. So I want to thank everybody for their help. And with that, I'll hand it back to Jeremy, I think.
All right. Well, I really want to thank our speakers, Omar and James. I also want to thank our live stream producer in the background and LabVIEW architect, Derek Bomarito. We are approaching our end time. We're going to officially end the presentation, but please feel free to stay on. We're going to keep the live stream open and answer any questions that y'all might have. So feel free to chime up in the chat. We've had some good conversations in there. If you have material you would like to present to the community, we would love to hear it. Please message me on LinkedIn if you have a topic that you'd like to share. In August, our next session in August, we're going to have Darren Gillis from NI talk about pushing the boundaries of WebVIs. You can build web applications with the LabVIEW NXG web module, and Darren goes further and talks about taking your web apps to the next level. All right, so thank you everybody for attending, and we will see you next time. And like I said, you can stay on the chat and we will keep answering questions.
I think I see one question about, could you explain the difference between using SystemLink local and a web service? So I think maybe that's a little unclear. So what I would say is that SystemLink is a web framework or web application framework, I guess, for NI is, I guess, an easy way to think of it. So the SystemLink server is a web server, and you end up having the ability to host that web server on your local on a local machine, or it can be on a physical server, usually behind your company firewall. On the client side, there's each client connection to the server is basically the way that the APIs can interface from your application layer into the actual SystemLink server itself. So I hope that makes it clear. I'm not sure if it does. So in order to use SystemLink, you have to basically have both ends present. You're not going to run it just the client.
So one other note on that, as far as like kind of where users are in relationship to where SystemLink things are, when you create, say, for example, a dashboard, the dashboard will generate like a permanent link. You can then hand that link to somebody, and as long as they have access like to the server some way, like if they're on the company intranet, for example, they'll be able to access and view that dashboard in, say, a run-only mode. We also at one point did a little experiment, and you can even make dashboards that are specifically designed for, say, an iPhone. And then if the iPhone has access, basically, depending on how the server is configured, if you have the server configured, say, to expose it to the internet, then, well, yeah, you could log in right now on your iPhone and see a dashboard.
Yeah. And I see Kevin Shuri posted, can you host multiple DBs within the API? So the way that it's set up, you can have multiple SystemLink servers, and they can talk to each other and form what NI calls a federation, which makes it possible to grow that way. You also have the ability to have the SystemLink server point at multiple data locations, but each server, I believe, only has one Mongo database connection. So the Mongo side is storing things like the meta results. So it's not very, well, depending on how you use it, but the way we're using it, it's very lightweight. So we don't expect that to have issues with data size for quite some time. But the ability to host the raw data itself, you can choose to have that hosted somewhere else and then pointed at from SystemLink, which is how you can enable not having your server get clogged up with too much data. Hope that makes sense. And I know that NI is actually, working on that as a longer term thing. Like they definitely care about making it possible for multiple SystemLink databases or servers to talk to each other. I'm not sure yet how they will handle it, but the federation thing is the current way.
I did see another question about kind of timeline from inception to deployment at VO. Did you have any thoughts on that, Omar?
Sorry, I did not see it. Wait, the timeline for for the code deployment, or what?
Inception to deployment, they said.
Oh, kind of not sure what you mean.
Make sure I'm reading.
Oh, from inception to deployment. I'm sorry. Now I see. Sorry. Yeah. So that's a good question. So we did it in a really phased approach. We started with a small pilot project, and I would say that getting off the ground was probably like a 1/4-ish of time, but that time was mostly spent not in actually development, but more in exploring how we want to use SystemLink. Not because it's a tool that has a lot of different ways you can use it. For example, those tags, you can use the tags for storing lots and lots of data in them, and they can have persistence, and you can choose that could be a place where data would live. But you can also choose that that might not be the place you want data to live forever, and you can have results, and test monitor results can go somewhere else. So sort of understanding which APIs to use and how you want to best fit those into your organizational needs, to me, that part took about 1/4. But in terms of getting off the ground and running, I was able to do some of the things that we showed in this presentation in about a day or a couple of days, just to get the sort of starting proof of concepts going. And that I would say that did not feel like a giant barrier to entry. One of the things I really appreciated about SystemLink compared to doing this kind of a project in a traditional way is that I did not need to have a database administrator. I did not need to get IT involved for very much at all. Basically, there was some IT help from of course, from our team to make sure that we were doing things in a way that we wanted to do things. But for the most part, we were able to do this in a very rapid, agile way that didn't depend on a lot of other cogs that traditionally these types of systems do require.
Well, if that's everybody's questions,
Yeah.
we appreciate again, we appreciate our speakers, and we especially appreciate you, our community. Please join us in August, and we will see you then.